Hello, everybody. Thanks for joining us today. My name's Joe Travellini. I'm one of the product managers on Amazon Elastic File System, or EFS. And I'm joined by a colleague, Prashant Bungale, from the Amazon FSX team. And we're excited to be talking about running file-based, business-critical applications in the cloud. So we've got a lot of great content to cover, so let's jump right in. So first, I'm going to give a quick introduction to the AWS File Services portfolio. Then I'll talk about capacity management, availability, and durability, and how to optimize your TCO. Then I'll hand it off to Prash to go over performance and data protection before we wrap things up. So before getting started, here's a couple of other sessions going on this week at re:Invent that you might also be interested in. Okay, so first, I'm going to go over how AWS makes it really easy to lift and shift existing applications into the cloud. And then once you are in the cloud, all the cool things that you can do there and transform your business. So speaking of, if you happen to attend the Storage State of the Union earlier this week, led by Kevin Miller, the general manager for S3, he talked about cloud adoption as a transformative journey. Now, I'm not going to spend a ton of time on this, but you can think about the journey in 3 phases: transforming your infrastructure, your architecture, and your business. So if you're attending today, you're thinking about moving business-critical applications to the cloud. You're probably in the first phase, maybe the second phase. That's where we're going to focus most of the content in this session. We'll talk about the architectural bits a little bit, and when I start talking about TCO and cost optimization, you'll start to see the benefits you can have to your business, although cost optimization is really just scratching the surface of the benefits that the cloud provides. So AWS offers 3 fully managed file system services today. The first, Amazon EFS, Elastic File System, targeted for Linux-based business applications. There's also FSX for Windows File Server, targeted for Windows-based business applications. We also offer Amazon FSX for Lustre, which is optimized for short-term compute-intensive workloads. So we're really going to focus on the first 2 services today, EFS and FSX for Windows File Server, which we're just going to refer to FSX from here on out in this session. All right, so what exactly is Amazon Elastic File System, or EFS? It's a scalable, elastic, cloud-native NFS file system. It's fully managed, so there's no infrastructure to maintain, and it grows and shrinks elastically as you add and remove files. It's designed to support a wide spectrum of performance needs, and it's designed to scale out to thousands of client connections simultaneously. It's cost-effective, with an effective price of just 8 cents per gigabyte per month. And I'll talk in more depth in the TCO section about exactly what that effective price means. It's designed for high availability and durability. We offer a number of security controls and enterprise compliances. And it's compatible both with your existing application stack and with other cloud-native services you might be planning to use in the future. With FSX, similar to EFS, it offers many of the same benefits. It's also fully managed and scalable. It's cost-effective, it's secure and compliant, and it's compatible with your current and your future needs. And with the hard disk drive, or HDD, offering that we just announced this week at re:Invent, you can get a Windows-native file system fully managed for as low as 1.3 cents per gigabyte per month. Now, we are going to focus mostly on the native file system storage services in this session, but we do want to talk about a little bit some of the data transfer capabilities that we have to move and to make it easier to migrate into the cloud. So here are 3 different services that AWS offers today. The first is AWS Data Sync. So Data Sync is an online data transfer service, uses an accelerated network protocol, and it allows you to move files into the cloud at up to 10 times faster than open source tools and at a fraction of the cost. Snowball and Snowmobile are 2 physical options that we have. So Snowball is a 47-pound portable device It lets you migrate up to 80 terabytes at a time at a very effective price point. Talk about that a little bit more later. It comes out to about 0.3 cents per gigabyte. Snowmobile, on the other hand, is a rugged shipping container that's pulled by a semi-trailer truck. With Snowmobile, you can transfer up to 100 petabytes at once into the cloud. So whether you're moving a handful of enterprise applications, maybe you're moving a whole data center, we give you various options to facilitate that. So just wrapping up this opening section here, think about it again in terms of that three-phase transformative journey. AWS makes it really easy to build a better infrastructure. If you use a fully managed service, you simply don't need to spend a lot of time or effort keeping the lights on. And once you're in the cloud, we give you the tools to make more of your data. And using that cost effectively, the insights that you generate from your data, you can transform your business. OK, so now you're probably thinking about, what does that actually mean in practice? How do I get started? Well, if you want to get up and running, moving a business-critical app into the cloud, I'm going to talk about some of the first-order operational considerations in terms of capacity planning and ensuring uptime. So whether you're running a Windows workload or a Linux workload, AWS makes it really easy to provision storage on demand. So let's talk about each of the file services in tandem. For EFS, you simply add and remove files. It grows and shrinks elastically. You don't have to worry about accommodating future growth. There's no provisioning necessary. FSX for Windows is also super easy. You create file systems anywhere from 32 gigabytes to 64 terabytes in size, and you can scale out to petabytes using Windows DFS namespaces. So with both services, there's little to no overhead in getting started. It's as simple as a few clicks and a few seconds to use fully managed file system services in the cloud. So let's talk a little bit more about fully managed services and the benefits that that provides. So you don't have to worry about setting up infrastructure, maintaining storage capacity, but you get several other benefits right out of the box. So when you want to ensure uptime for a business-critical app, AWS fully managed file services have built-in redundancy with no single points of failure. EFS and FSX both spread data within an availability zone and across availability zones to provide high levels of availability and durability. So EFS is a regional service. You create network interfaces called mount targets in each availability zone where you want to access your file system. And the DNS name for your file system has some AZ awareness built in. It automatically resolves to the right mount target, meaning the one that's in the same AZ as the client making the request. So that optimizes your footprint, keeps your network traffic co-located in a single AZ. There's no transfer charges necessary, and it optimizes performance as well, co-locating it for lowest latency. And similarly, on the back end, Amazon EFS's distributed architecture avoids the traditional bottlenecks you see in an on-premises filer. So Amazon FSX provides high availability and durability, continuously monitoring for hardware failures and replicating data across availability zone. So we recently launched multi-AZ file systems for FSX. Those provide continuous availability even in the event of disruption to an AZ. So in a multi-AZ setup, FSX will automatically provision a standby file server and fail over to it when needed and automatically fail back upon recovery. And again, when you're using a fully managed service, you get these capabilities included in the service price. So it's basically right off the top. We'll talk more about pricing and TCO in the next section here. And one last thing I wanted to call out is that both services offer a 3 nines, 99.9% service level agreement, or SLA. OK, so let's talk about how to optimize for cost when running in the cloud. So AWS offers the lowest cost, fully managed file system services in the cloud today. With EFS, you can provision petabytes of data at an effective price point of just 8 cents per gigabyte per month. And part of how you realize that effective price point is by transparently tiering your data across the two EFS storage classes, EFS Standard and EFS Infrequent Access, or IA. So we'll talk more about IA in just a little bit. What we see, there's a generally accepted industry standard that 80% of data in the fullness of time is infrequently accessed. And we actually validated that estimate using our own usage data analysis. So if you take that blended price, 80% infrequently accessed, 20% frequently accessed, that equates to 8 cents per gigabyte per month with EFS. And for FSX, we announced that HDD offering for your Windows file systems. You can store in a single AZ at just 1.3 cents per gig per month, or in a multi-AZ setup for 2.5 cents per gig per month. You can also save around an additional 50% using our native data deduplication capability. All right, so now I'm going to talk about each service's SKU and its pricing in a little more depth, and then we'll do a TCO analysis, juxtaposing it against a do-it-yourself setup. So EFS pricing, you can kind of think of in 3 categories. We'll start with storage. EFS Standard costs 30 cents per gigabyte per month. And again, included in that price point, you get all the abilities that EFS provides: scalability, elasticity, simplicity, availability, and durability. Those are all included in that 30 cents. And that's also inclusive of any network and request charges. You don't have any of those when using EFS Standard. EFS IA, on the other hand, it's cost optimized for files you're not using every day. And again, that price point is 2.5 cents per gig per month, 92% less than EFS Standard. So you have the option to transparently tier your data into IA. When you do that, another thing you want to think about is data access and throughput. So with EFS, Prash is going to talk more about it in the performance section, but you have the ability to provision throughput independently from storage. You get 50 kilobytes per second included per gigabyte of standard storage. That's part of the standard price. But if you want to provision additional throughput, that costs $6 per megabyte per second per month. And with EFS IA, each time you read or write a file, it's 1 cent per gigabyte. With EFS, you can also natively back up with AWS Backup service. Prash will talk about backups for both services in just a few minutes here. But backups cost 5 cents per gigabyte per month for the warm tier, or you can lifecycle them off into the cold tier for 1 cent per gigabyte per month. With FSX, you pay for the storage and the throughput capacity you choose for your file system, as well as any other backups that you create for your FSX for Windows file system. Solid-state storage costs 13 cents per gig per month in a single AZ setup and 23 cents per gig per month in multi-AZ. The newly announced hard disk drive back storage, again, 1.3 cents in single AZ, 2.5 cents in multi-AZ. And throughput capacity is just $2.2 per meg per second per month in single AZ and $4.50 per meg per second per month in multi-AZ. And again, included in the service price, you get all the abilities a fully managed file native service provides. And just like EFS, FSX backups also cost 5 cents per gig per month. So here's a lens looking at FSX pricing when you take dedupe into account. So what we see, it varies on your workload and the nature of your data, but typically you save around 50 to 60% when using dedupe. So keep in mind, SSD storage effectively, 6.5 cents per gig per month in single AZ, and HDD storage is just 1/10 of that at 0.65 cents per gig per month. All right, so I just threw a lot of numbers at you. Let's take a step back, look at what it would take to do it yourself if you wanted to operate a self-managed file system, all the different components involved in that, the hard costs, the soft costs, and the complexity. So obviously you're going to have EC2 instances as your clients. You're also going to want to provision EC2 instances to run the file servers themselves. Then you might want EBS volumes attached to those file servers, maybe some solid state, maybe some HDD, and then if you're going to tier, you might have custom scripts to tier data. You can see it gets pretty involved pretty quickly. And if you require high availability, maybe you mirror the entire setup. Maybe you mirror the entire setup in a second AZ. By definition, you're doubling your cost right off the bat. But then you also have to pay for the network traffic to replicate and synchronize the data across those two AZs. So again, there's a lot of different components involved here. So I'm going to use EFS as an example, just doing the TCO analysis, a fully managed service versus doing it yourself. So let's say you want to operate 500 gigabytes of storage in the cloud. Again, using that estimate that 80% of your data is infrequently accessed and 20% of it is frequently accessed, it's 400 gigs of EFS IA data and 100 gigs of EFS standard data. So you see, that tallies up to about $44 per month. I did want to mention the data access component here. We use a pretty conservative estimate in this analysis that your infrequently accessed data, you access it once in full per month. That's what we recommend just from a planning perspective. What we see in practice is actually considerably lower than that. So you compare it to a do-it-yourself setup. You have your storage volumes, maybe your solid state, and your HDD. You've got your compute capacity to run your file servers, and you've got some network bandwidth to handle the replication and the availability traffic. And when you tally it all up, it's about $459. So if you choose to use a fully managed service in lieu of doing it yourself, you can save up to 90%. So I'll talk a little bit about some of the features each of the services offer to optimize for cost. We talked about EFS and frequent access a little bit. Here's how it works at a high level. You simply need to enable lifecycle management for your file system. Lifecycle management is a capability that monitors the access patterns of files in your file system. It tracks every file's access time individually using a timer. So when you enable lifecycle management, you choose a policy corresponding to your file system. We offer a number of different policies today, 7, 14, 30, 60, and 90 days since last access. So it's actually the access time, not the creation time we're using in EFS. So we see a natural correlation in the age of a file and how frequently it's accessed. Older files tend to get accessed less frequently. But what we do is we track it file by file. And anytime you don't access a file, let's say for 30 days, you pick the 30-day policy, we'll automatically move that file transparently from EFS standard into EFS IA. From a user perspective, from an application perspective, it's the same file, it's in the same file system, in the same path. There's really no difference noted logically, but under the hood, it's in a different storage class, and it has a different price point. So for FSX, you choose the optimal storage based upon your performance needs. This works in a single AZ or in a multi-AZ setup. On top of that, again, you can save up to 50% or around 50% with data dedupe. And you separately provision your storage and your throughput so you can allocate only the resources that your applications need. So one final area to consider from a cost perspective is in migration when you're trying to optimize for cost. So I'm going to compare DataSync and Snowball here. There's really a time and cost trade-off that you can think about when trying to select which migration service to use. So DataSync costs just 1.25 cents per gigabyte transferred. And generally speaking, for relatively smaller data sets, that's going to be your quickest migration option. You can also choose to provision multiple DataSync agents to accelerate your transfer, especially if you're using like a dedicated connection like AWS Direct Connect. On Snowball, it's going to help you migrate large data sets quickly and cost effectively. I think I mentioned earlier, when you transfer the full 80 terabytes, it comes out to about 0.3 cents per gigabyte transferred. And of course, there's a little bit of extra time needed for the shipping from AWS to your data center and back. But again, it's a time and cost trade-off that you can think about when you're moving your business-critical apps to the cloud. And with that, I'll hand it over to Prash to go over performance and the rest of the topics.
Thanks, Joe. So just to orient ourselves, Joe introduced the services, EFS and FSX for Windows File Server, and he already talked about some of the availability and durability features, as well as the total cost of ownership considerations and optimizing TCO. I'll now cover a few other areas, the first one being performance. So we actually built these file services from the ground up, taking performance into consideration as one of the critical factors that customers need. So let's talk about the performance aspects of these services one by one. So with Amazon EFS, you get performance and scale as shown on this slide. The latency is single-digit millisecond on average for EFS standard storage, and the latency is double-digit millisecond for EFS infrequently accessed storage. In terms of throughput and IOPS, which tends to be really important for performance-sensitive applications, EFS can provide up to tens of gigabytes per second of throughput and hundreds of thousands of IOPS, over 500K IOPS per file system. So really, you can meet the needs of your high-performance applications. Let's talk about some of the options you have with EFS in terms of performance. So EFS provides two separate performance modes. The first one is called general purpose, and the other one is called max IO. The general purpose performance mode is the default mode, and it's really the mode that we recommend most applications use and start off with. It's recommended for the vast majority of workloads out there. Max IO, on the other hand, is meant for scale-out workloads, data-heavy, data-intensive workloads. Let's talk about comparing and contrasting these two performance modes. In terms of what it's for, general-purpose performance mode is really meant for latency-sensitive applications and for general-purpose file-based workloads. The max IO mode, on the other hand, is meant, as I mentioned earlier, for large-scale and data-heavy applications that require a lot of scale-out performance. In terms of advantages and trade-offs, the general-purpose performance mode provides the lowest latencies for per file operation latency. The trade-off is that it has an IOPS limit. The current limit for the number of IOPS per file system is 7,000. And we just announced a couple of days back that we are going to be increasing that limit by about 5x to 35,000 IOPS for read operations per file system. On the other hand, the max IO performance mode provides you, hundreds of thousands of IOPS, virtually unlimited ability to scale out throughput and IOPS, with the trade-off being that you have slightly higher per file operation latency for metadata operations. In terms of when you would use each of these modes for your use cases, the general purpose is really the best choice for most workloads. So if you are not sure about which mode to use, we really recommend that you start off by using that and test your application or workload. And max IO, on the other hand, you should consider for large scale-out workloads. EFS also provides two different modes for throughput. The first mode is bursting throughput mode, which is the default. And again, this is the one that we recommend for the vast majority of workloads out there. We have actually built experience over many years across tens of thousands of customers, and we have observed file-based workloads to be spiky in general. And for such spiky workloads, what we have designed and built to meet the needs of those workloads is the capability to burst your throughput for short periods of time to a level that's above the baseline level. So that's really the default mode that we recommend for most workloads. On the other hand, EFS also provides another throughput mode called provisioned throughput, which is recommended for applications and use cases that require a higher throughput and that require that higher throughput on a consistent basis, on a sustained basis. This is especially true for applications that have a higher throughput to storage ratio. So let's talk about what that means a little bit. The bursting throughput mode is really useful for workloads that have varying throughput needs over time. The provision throughput mode is really the right one if you want a higher throughput to storage ratio and also a more consistent higher throughput need. In terms of advantages and trade-offs, the bursting throughput mode provides you automatically scaling throughput because your throughput scales with your storage. So the way it works is you get 50 megabytes per second per terabyte of storage. As you scale your storage, you get higher throughput. And in terms of burst throughput, you get 100 megabytes per second per terabyte of storage. So both your baseline and your burst throughput scale with your storage. In terms of how the burst credits work over there, basically you get a number of burst credits that's dependent on your storage to begin with. And then as you go over time, as you use your file system, as you drive activity against your file system, if you're driving at the baseline level, then you're neither accumulating burst credits nor consuming burst credits. If you are driving a throughput level that's higher than the baseline, then you're consuming burst credits. If you're driving a throughput level that's lower than the baseline, then you're accumulating extra burst credits. So it's a pretty simple burst bucket model, consistent with some of the other AWS services that have a similar kind of burst credit model, like EBS GP2, for example. In terms of the trade-off here, you have a fixed throughput to storage ratio. So what that means is if you need a higher throughput, you generally also have to have higher storage. Now, this is where the other mode comes into the picture. If you have an application or use case that has a relatively low amount of storage, but a relatively higher throughput need, then really the provision throughput mode is the right mode for you because you get to define, you as the user get to define the throughput that you need for your application. The trade-off here, of course, is that there's a separate provision throughput charge separate from the storage price point. In terms of when to use, as I mentioned, the bursting throughput mode is really the one that we would recommend as the best choice for most workloads. That's where we would recommend you start with testing your workload. And then if you know that you have a higher throughput to storage ratio, of course, provision throughput mode is the right mode to start with. And also, there's another scenario where provision throughput comes very handy, which is if you're initially loading a lot of data into your file system. Specifically, if you're loading more than about 2 terabytes of data, then the provision throughput mode is especially helpful, at least during that initialization phase. So let's talk about performance on Amazon FSX now. In terms of latency, FSX offers sub-millisecond per operation latencies with SSD storage. In terms of throughput and IOPS, if you are going directly to the file server, if your application is driving SMB operations, read or write operations directly against the file server by using what is called direct I/O, then you get up to 3 gigabytes per second of throughput and hundreds of thousands of IOPS per file share. If your application is able to take advantage of client-side caching, which most Windows workloads are actually by default, you can get up to 10 plus gigabytes per second of throughput and millions of IOPS on a per file share basis. So with every Amazon FSX file system, you get to define how much storage capacity you want for it and also how much throughput capacity you want for it. The throughput capacity is what determines the speed at which the file server that's hosting your file system can serve file data to your clients and applications that are accessing the file system. Higher levels of throughput capacity also come with higher levels of IOPS and more memory for in-memory caching on the file server. In terms of throughput capacity options, we provide you a wide range of options, starting at 8 megabytes per second, going all the way to 2 gigabytes per second. And the key point here is you're actually picking the throughput capacity, as Joe mentioned in the TCO section, independently from the storage capacity. So what that means is, depending on your application's specific performance needs, you get to decide how much throughput you want to assign for your file system. If you have a low storage requirement and a high throughput requirement, you can do that. Or on the other hand, you can actually save costs if you don't require that much throughput for a colder workload, for example. The throughput capacity itself, the 8 megabytes per second to 2 gigabytes per second, is the baseline throughput, meaning this is what you get on a sustained 24/7 basis. You also have the ability to burst to higher levels of throughput. Again, as I mentioned, we have seen that file workloads are spiky in nature. And so to support the burst needs of these applications, we support burst throughput as well at each of these throughput capacity levels. So for example, with the lowest throughput capacity level of 8 megabytes per second, you get a burst throughput capability of 192 megabytes per second. And you get this capability for about 30 minutes a day. So as long as your application doesn't spike to above about 200 megabytes per second for more than 30 minutes a day, that lowest level should be more than sufficient for your application, just as an example. Now, these throughput numbers are all considering going all the way back to the storage volumes or disks behind your file server. A lot of applications and workloads are actually amenable to taking advantage of in-memory caching on the file server side. For those cases, you get even higher throughput with in-memory caching. And there you can get anywhere between 600 megabytes per second on the lower throughput capacity levels, all the way up to 3 gigabytes per second at the highest throughput capacity level. So really, you can think of Amazon EFS and FSX as both providing really high performance and scale to meet the needs of your applications and workloads. So let's move to the next section now, where we'll talk about authentication, authorization, and access controls. So let's first talk about the file services as a whole, and then we'll dive into some of the specifics on each service. In terms of access controls, as is consistent with a lot of other AWS services, we provide you the ability of being able to control your network traffic. You can use Amazon VPC and VPC security groups and network ACLs to control network traffic. For example, you can say this group of EC2 instances is assigned a specific security group, and that group should be able to access, whereas these other groups should not be able to access my file system. You can also control access at an individual file and directory level. So here, with EFS, you can use POSIX permissions to basically say this user or group can read or write this file, whereas this user or group cannot. With FSX, you get to use Windows NTFS native file and folder level access controls, or ACLs. And you also get to use SMB share level access controls. So with that, again, you can have a rich set of access control lists. You can basically have a list of these 8 users being able to access the file or folder in a specific way, these other groups not being able to access it in these other specific ways. So you can really have rich and fine-grained access control on file and folder level access. You can also control administrative access. So what we mean by that is using AWS Identity and Access Management, IAM, you can actually control who can call create APIs, who can call delete APIs, and so on. So you can control who gets to manage your file system resources, your backup resources, and so on. And you can use action level and resource level permissions, as well as apply resource-based policies via IAM. Let's talk about authentication and authorization. With EFS, we announced that coming soon, you will actually be able to control, using IAM, which clients can access your file system. And here what I mean is which clients can mount your file system and actually connect to the file system before they're able to access files and folders. So we already support IAM, as I mentioned in the previous slide, for being able to control at an API level who gets to do what. Now we are extending that IAM integration to also be able to control which client gets to connect and not. So the canonical example for the use of IAM here is EC2 instances have instance profiles associated with them, and the instance profile has an IAM role associated. So you can basically use the IAM roles to specify these EC2 instances should be able to mount my file system, these EC2 instances should not. We also announced that you will soon be able to use policy-driven enforcement to basically do things like require encryption, being able to limit to read-only mounts, being able to restrict root access using this IAM level integration. On FSX, You can directly integrate your FSX file systems with your organization's Active Directory and provide authentication and authorization that way. Your users continue to access your file shares by authenticating with existing AD credentials. They don't have to take on new user identities, sign on again, or things like that. They continue to use their existing sign-on to basically access file shares. And in terms of authorization, you can migrate and use your existing file and folder level ACLs and your share level access controls without any modifications. We support 2 different AD integration options: AWS managed Microsoft AD and also your own self-managed Microsoft AD, if you're doing it on premises or in cloud, either way. Just as an illustration of how easy it is to use your own Active Directory with FSX, on the console, when you're creating a file system, there's a section called Windows Authentication. All you have to do is select self-managed Microsoft Active Directory and provide your DNS server's IP addresses, your domain name, and your service account username and password, and that's it. We join the file system to your domain, and then all of your file and folder level ACLs, your user authentication continues to work with your existing Active Directory. So let's move on to the last section before we wrap up, which is data confidentiality and protection. We provide transparent encryption across the file services. There's no need to modify your applications to benefit from encryption and security features. We encrypt data at rest. We integrate with AWS Key Management Service, or KMS. And we support both service-owned keys on KMS as well as customer-managed CMKs on KMS, which uses the industry standard AES 256 algorithm as well. And in terms of encryption of data in transit, we support being able to mount your file system over TLS version 1.2 network tunnel on EFS. And on FSX, we support encryption of data in transit using SMB Kerberos using your Active Directory. We also recently launched support on both the services. On EFS, it's coming soon, and on FSX, we launched it on November 20th. This is the option to enforce encryption in transit, meaning we already supported encryption in transit, but now you as an administrator can go decide every connection to this file system should now be encrypted in transit. And in terms of compliances, we support a whole range of compliances, HIPAA, GDPR, PCI, SOC, ISO, and so on. And EFS also supports FedRAMP. We also provide you a rich set of features around additional data protection natively. So on EFS, we integrate with AWS Backup, and we allow you to take backups of your EFS file systems. You get to centrally manage all of your backup resources across AWS services. So whether it's backups of EBS volumes, backups of RDS databases, or EFS file systems. You can also do automatic or on-demand scheduling of these backups. And you can choose between full and incremental backups. And very soon, you'll also be able to restore individual files or folders from these backups that you have taken using AWS Backup. On FSX, we provide native automatic daily backups that are enabled by default. And you as an administrator can also initiate a backup at any point in time, in addition to these automatic daily backups that we provide. The backups themselves, I'll go into a little more detail about what these are and what kind of benefits they provide in a slide or two. And then in addition to the backups, we also support file system snapshots via Windows shadow copies. And using this, you can basically support individual file or folder level restore. On EFS, as I mentioned, we integrate with AWS Backup, and you get to back up your EFS file systems and restore them as well using the AWS Backup service. The backups themselves they provide 2 classes of service. There's warm storage and there's cold storage. And Joe already talked about the TCO implications of these two. Warm storage is 5 cents per gigabyte month. Cold storage is 1 cent per gigabyte month. The ability to life cycle across warm and cold as well comes along with AWS Backup. And then it also provides backup scheduling and retention based on your policy that you get to define. And then very soon, as I mentioned, you'll be able to restore individual files or folders. With FSX, the backups themselves are highly durable. They're stored in Amazon S3, so you get the 11 nines of durability. The backups are also file system consistent, meaning that you can capture and restore point-in-time snapshots of your file system. And then it ensures file system consistency using the Windows native volume shadow copy service, or VSS. The backups are also incremental, meaning that only the changes since your most recent backup would consume additional backup storage and would cost you the backup storage price. And they're fully managed, meaning that the service takes care of taking the automatic daily backups, applying the retention policy, and also allowing you to take admin-initiated backups at any point in time, either using the API or the console. So here what I'm showing you is the fact that we provide you both the daily automatic backups as well as the admin-initiated backups. For the daily automatic backups, the default is actually that daily automatics are enabled, and you get to specify the retention policy. The default is 7 days, but you can change the retention policy for that, and we will automatically apply that retention policy for your backups. And then in addition to this, you can initiate a backup at any point in time, and we even provide you a backup scheduling solution on our documentation and user guide, using which you can basically apply generic backup retention policies, like I want to maintain daily backups for 7 days, weekly backups for 6 weeks, monthly backups for 7 years, things like that. So you get a rich set of functionality around backups, scheduling, and retention policy. We also allow end users to restore individual files or folders in FSX without involving the administrator in the loop. So what this means is if an end user has deleted a file accidentally and wants to recover it, they need not page their administrator or go to their help desk or something like that. The end users can themselves have self-service to go and undo the changes to individual files or folders. They can also compare previous versions very easily. So the screenshot over here shows you how simple it is. You can basically right-click on a file or folder, say properties, and go to previous versions. And then you can say, OK, I want to go back to Monday's version. And lastly, I'll talk about AWS Monitoring and Auditing. So we provide support for Amazon CloudWatch and AWS CloudTrail across both the EFS and FSX services. We allow you to log your API calls using CloudTrail, and we also support metrics, dashboards, and alarms using CloudWatch. So let's do a brief summary, and then we'll accept some questions. So on EFS, here are a few sort of tips for migration best practices. We generally recommend that you start testing with your general purpose performance mode. And then, based on your application needs, consider using Max.io in a specific subset of cases, as I mentioned earlier. We enable encryption at rest and in transit for sensitive. We recommend that you enable encryption at rest and in transit for sensitive workloads. And we recommend that you enable lifecycle management where it makes sense in order to save automatically up to 92%. And we generally recommend that you create a backup plan to further protect your data, in addition to the fully managed durability that EFS already provides. And we recommend that you consider provision throughput if you're loading more than 2 terabytes of data, as I mentioned earlier. And finally, we recommend that you monitor your throughput utilization, your burst credit utilization, and your IOPS limit when it comes to general purpose performance mode. And we provide a pretty simple solution that you can use on Git to be able to, in a very simple way, monitor these things and find out if you need to change anything in terms of configuration on your file system. On FSX, we support a simple and seamless migration path. So we recommend that you migrate your files and folders using Windows native tools like Robocopy. And this is in order to make sure that you're not just transferring your files and folders in terms of data, but also transferring the critical Windows native metadata that often are very important for enterprise use cases, things like NTFS access controls, things like ownership information, auditing controls, timestamps, and things like that. You can also preserve all of your existing ACLs and DFS namespace names and your existing UNC path names so that your applications and users can continue to access the files and folders using the existing path names without any modifications whatsoever. Customers have told us that oftentimes you actually have hard-coded in your workflows or in your applications or sometimes even embedded inside Excel spreadsheets your UNC path names for your file shares. And so you don't want to be going around searching for all of these path names and changing them to the new path name if there is a new one. So we support using your existing names without needing to go change all of these things. Go dig around, first of all, before changing this. And also, the key thing here that I mentioned already was your users can continue to access your shared file systems in the exact same way they have been doing all along, which is using their existing AD user identities. And finally, recently we launched support for programmatic share management on November 20th. We launched this feature. With that feature, what you can do is, in a very simple way, you can import all of your SMB share configuration on your existing file storage, on your NAS file storage, and you can migrate all of that share configuration information over to FSX. We provide a very simple migration tooling on our documentation. You can use that tooling to basically, in a programmatic, automatic way, transfer all of the share information without needing to click around a lot of buttons on the Windows GUI. So essentially, in summary, you can migrate your existing business-critical file storage over to the cloud while keeping your applications and end users' access patterns and access modes the same, meaning that there's no need to modify your existing applications or user workflows. That's really our goal here. So I'll pause there, and we'll be happy to accept any questions. Please make sure you come to the microphone before you ask your question.
I work for an organization that spends an awful lot of, we put most of our storage in S3. You probably get this question a lot. Why would you choose EFS versus S3 if we're talking EC2 or even, I'm guessing this could work with ECS as well. I'm not certain, so if you could touch on those points, that'd be great.
Sure, I can address that for you. I mean, we see a number of customers using S3 as a data lake. If your organizational strategy is to consolidate all your data in a massive data lake that's accessible for multiple users and groups, that's one paradigm we see. With EFS, one of the things EFS is designed for is to shorten your time to value. So if you have an existing application that expects file, it's easy to lift and shift that into the cloud. One thing to keep in mind with S3, object inherently lacks intrinsic data structure, and you have to impose that in an application layer. With EFS, file systems have an intrinsic data structure in the file system directory hierarchy. So a lot of algorithms expect file, a lot of applications expect file. Ultimately, it's a trade-off. If you have use cases with S3 integrating with other services, EFS also integrates with many services. Over time, we'll continue to do that.
What about ECS?
So many customers use EFS for persistent shared storage in a containerized environment. Using ECS today, it is possible to mount EFS, whether you bake it into your container image or you use a user data script to mount the file system after the container launches.
Okay. And I assume there's documentation on all that?
We do.
Excellent.
And just to add to what Joe mentioned, in terms of object versus file, one thing I'll say is it basically comes down to the application interface that you want to use and that you're comfortable with and that works for your use case. So with object interface, there's a specific set of semantics, if you will, which basically talk about the way you access it is via gets and puts and things like that. And then there's a specific consistency model, there's a specific performance profile and all of that. So there's a whole bunch of application access characteristics that go along with the object interface on the one hand. On the file interface, on the other hand, as Joe mentioned, there's the directory hierarchy, but there's also things like file locking and being able to cache file content locally while still having a single source of truth being the file system. There are all these protocols that have built the logic of being able to lock files in specific ways and things like that, and also lock specific portions of files, not just files. You can do at a sub-file level, read and write and lock and things like that. So there's a rich set of functionality on both ends. It's about which interface works for you.
Over here.
Sorry, I may have missed this and I missed the beginning, but are these services available only in the cloud or on-prem, like through a storage gateway or something like that?
Sure. So you can access EFS over AWS Direct Connect via VPN. One thing to keep in mind there is just latency considerations, physical speed of light constraints. EFS is accessible from on-premises as well, if you want to talk to FSX.
Yeah, and FSX is the same. The fully managed file storage is provided in the cloud for you. And then we allow access from Direct Connect or VPN from your on-premises locations. We also allow cross-region access, cross-account access, cross-VPC access using VPC peering or transit gateway. So we allow a rich set of network connectivity access across both these services, across both EFS and FSX. And the file storage itself is in the cloud, and it's fully managed for you.
Okay, so that's what I was worried about, the latency. Because I use the file gateway, and that provides a local, I guess, a cache of the files that are more often used. And I was wondering if there was something like that. So I will experience latency if I use this.
File gateway today works with S3. EFS is a fully managed cloud-native file system.
Okay. Yeah, but just to answer your question about caching in particular, though, so with FSX, for example, you can actually get client-side caching. So we support the full set of SMB features around caching, things like opportunistic locks on SMB, client-side leases that you can take from SMB protocol, and so on. And what that does for you is the first time you access the file or folder, you actually go over the network and fetch the data from the cloud. And the second time onwards, your client is able to cache the content locally and save on the network access, both in terms of time as well as data transfer costs.
Okay. Thank you.
I have two questions. We've been using EFS for the last 4 or 5 years, ever since it was available in beta. The first question is, what will be the recommended throughput mode and burst mode or setup for applications that require a lot of metadata access to imagery? We have a custom ecom application that every time we do a deployment, the core of the application, something we cannot change, goes through the entire catalog of imagery, and it attempts to find if all of the existing thumbnails are there, if all of the tiny little icons are there, and as the catalog grows, we accumulate more and more and more images. So at the end of the day, we have close to 300 gigs worth of imagery, and we don't see network traffic. We don't see a lot of IOPS. We just see a lot of metadata requests, and usually EFS becomes a bottleneck. So what will be the recommended setup for that setup?
So general purpose mode will offer the lowest metadata latencies EFS is capable of, whereas max IO mode will offer the highest levels of aggregate throughput that EFS is capable of. And Prash talked about the trade-off of an IOPS limit. We do recommend general purpose mode for metadata intensive workloads. Okay. We did announce this week we're increasing that IOPS limit 5 times for the reads coming soon. Monitor your throughput and monitor your IOPS. While that is the recommendation, if you have higher throughput needs, particularly in parallel, you may want to consider max IO, but we recommend definitely starting with general purpose for metadata workloads.
Excellent, thank you. And the second question is, again, related to EFS. Is it possible to access or mount an EFS share across account by the use of a VPC endpoint, via Direct Connect? So I have a customer that owns their own account. We have our account. We run the EFS share on our account because that's where the application is. There's a secondary app that the customer runs on their account because that's their workload is, and we have a direct connect between the two, or private link, if you will. Is it possible to do that?
You should be able to do that using either VPC peering or transit gateway.
Okay, thanks.
Sure.
Thanks.
Over here.
Yeah, I just wanted to understand how you guys handle the multi-protocol with EFS and FSX. Let's say if I have my client who wants to access the file data from a Windows box and a Linux box, for example. So how is EFS and FSX handling the multi-protocol today?
Yeah, so with FSX for Windows File Server, what we support is access from a range of different operating systems on the client side. So we support access from Windows clients, whether it's Windows Server, any version from 2008 onwards to the latest version, or it's Windows desktop versions, any version after 7, Windows 7, as well as Linux operating system using the open source SMB client on Linux, as well as macOS. So we support a broad range of operating systems in terms of the client accessing the file system. So if you have a mix of Windows and Linux users and clients needing to access your file system, you should consider using FSX for Windows.
Over here.
Yeah, is it possible to direct the backups to another region for DR purposes?
Sorry, which service are you referring to?
Either EFS or FSX?
So the question is, can you move the backups to a different region?
Right, yeah.
I'd have to follow up on that. Primarily, you take them in the same region. Whether AWS Backup can move those to another region, I'd have to get back to you on that.
Okay, and then for FSX?
For FSX, we don't have the capability today to transfer your backup to another region. It is something that we are definitely looking into.
Okay, thank you.
Can you talk about performance penalty of infrequent access? Is it IOPS lower? Is there a warm-up time? Is there higher latency before
Sure.
When you access that data?
Yeah, so that's a great question. What we see is the first byte latency on average for infrequent access is in double-digit milliseconds compared to single-digit on EFS standard. But what we see in practice when customers test from a performance perspective, depending on your workload, particularly if it's a read-heavy workload, we've had customers report that there's no perceivable difference between standard and IA. So while there is, that first byte latency addition, if you're reading the same, like Prash talked about caching for FSX, NFS clients also cache data once they read it. So not only will you not have to pay the performance penalty multiple times reading the same file from the same client, but you're also not paying the data access charge. Yep.
With regards to FSX, does it support the full Windows like branch cache and everything for local client-side caching? So we've got lots of remote sites, but we have small footprint of infrastructure there. Could we set up branch caching for them?
Yeah, so today we support client-side caching using the full set of SMB client-side caching features that I talked about earlier, as well as we support caching using the feature called offline files, where you can designate certain files or folders from the client as being offline, and then you can sync them to the file system at a time that you choose. We don't support branch cache today, but it is something that we are hearing feedback from customers about, and we are considering it.
Thanks.
Okay, thanks so much.
everybody.
We are also available to take additional questions if you have any. Thank you.